Hello, bonjour, it's Laura here. In this video, I'm going to talk about how you can use balanced equations to solve some really good chemistry problems. So this is going to be a really big skill that you'll use later on when we do more complicated problems. So the first thing that I want you to remember is always start with a balanced chemical equation when you're solving chemistry problems. Now, a balanced equation is a lot like a recipe. So, for example, you could have a recipe for cookies where you need like 2 cups of flour, 1 cup of sugar, 3/4 cups of butter, and then that's going to make 24 cookies. So this would be like a balanced equation. It's really specific. It's telling us we need 2 cups, 1 cup, 3/4 cup, and then we're going to get 24 cookies. So it's really specific information. And it's measured. An unbalanced equation is not specific. It's not like a recipe. It's more like just having a bunch of unmeasured ingredients on a counter, kind of waiting to be measured out. So if you have something like this, like flour plus sugar plus butter equals cookies, that's not enough information. And students sometimes get confused because they'll see an unbalanced equation and they think that that's enough information, but it's not. It doesn't actually tell you how many moles you need of each thing or each reactant to end up with a certain number of products. Just saying flour, sugar, and butter, that's not enough information. I could just take a handful of this, a bag of that, and I'm just going to end up with a big mess. I'm not going to end up with cookies. Okay, so always start with a balanced chemical equation. So a balanced chemical equation is a lot like a recipe. So for example, I've got a Bannock recipe here. It's got 2 cups of all-purpose flour, 1 tablespoon of baking soda, 1.5 teaspoons of salt, 1/2 cup of milk, 1/2 cup of water. That's really specific information, and then that's going to produce for us 10 pieces of Bannock. So from that information, we can take a lot of different recipes or different ratios from that. So for example, what's the relationship between flour and salt? So you'd look here, we've got 2 cups of flour. So the relationship there is 2 cups of flour. And then how many teaspoons of salt? That would be 1/2 teaspoon of salt. So that's a ratio, and we could actually turn that into a conversion factor as well. 1 cup of, or how much for milk to water? So 1/2 cup of milk and 1/2 cup of water. What about flour? 2 cups of flour to how many pieces of Bannock? We could make 10 pieces of Bannock. So there's all kinds of different ratios that we can get from that. All right. So what if you don't need just 10 pieces of Bannock? What if you need some weird number like 51 pieces of Bannock? What are you going to do? You can't just multiply by 2 or something like that. Like if you needed 20 pieces of Bannock, you could just multiply the whole recipe by 2, and that would be pretty simple. But this math isn't as easy. So what you could do is take those ratios that we're talking about and make conversion factors with them. So say I want to calculate the amount of flour. The information I'm given is the 51 pieces of Bannock. That's how many I need, or I'm given. What do I need? I need cups of flour. And then what's the equality? What's the relationship between Bannock and cups of flour? And that I take from the recipe. So the 2 cups of flour here is going to give me 10 pieces of Bannock. So that's my equality, and I can set that up into a conversion factor. Oops. So the information I'm given is 51 pieces of Bannock. That's how many I need. And then I want to multiply that by a conversion factor. that I take from my equality. So I need bannock to be on the bottom, the pieces of bannock. And then on the top, I need to have my cups of flour. And I take that from my equality. So 2 cups of flour is going to give me 10 pieces of bannock. Sorry, that's really messy. I'm just going to erase that here. Okay. It's nice that this is a good eraser. Okay, so then when I do that multiplication, I'm going to get 10.2 cups of flour. And notice I've canceled out my pieces of bannock, and then I'm left with my cups of flour. Okay, so just like we were doing with donuts before, showing you kind of a real life example, this would be a real life example, and then you're going to use the exact same steps for doing some chemistry problems. Okay, well done, miigwech.